Hello, let us begin by introducing our robots. This is Hans.
And this is Ron.
And they want to pump
You up! Their muscles are so large and they are very sturdy and fast.
Yeah, they're so talented in everything they do. They can achieve a max score of 605 points during the robot game.
Stop! Let's get serious! We kicked off our season by setting team goals for building, coding, and teamwork to make sure everybody on our team got the chance to contribute. From the very start, we practiced inclusion by splitting into 3 separate teams, each building a unique robot. Then we took the best aspects from each robot, such as the rack and pinion system, the wheel size, and sensor placement, into one final robot. We even built a second identical robot to make sure everybody was involved during practice. Our robot is compact with a low center of gravity. It's perfectly symmetrical with a ball caster for stability. Our front rack and pinion system is powered by a large motor, and our back features a medium motor for additional attachments. We also use our 2 color sensors for line square.
We built our robot for maximum efficiency. We have a universal attachment base for the back, secured by a simple upward axle. All our back attachments connect exactly the same. For the front attachment, the rack and pinion part, the attachment clips in easily with long blue pegs. Using both the front and back attachment allows us to achieve more missions per run. Our robot has a square shape allowing for easy alignment in home base and quick launches.
Our attachments are designed to be multifunctional. We rely on passive mechanisms whenever possible to save motor power for more complex tasks. We like to highlight this attachment here, which uses these angled beams to lift the mast, with these limitations here to prevent overextension, while at the same time this one-way grabber securely retrieves the treasure chest. And this attachment here, which uses a passive mechanism to dump the samples into the boat, while also pushing the boat into the latch. And this rubber band mechanism here flips around the artificial habitat, so we can then use an arm to score for all 40 points. We're especially proud that our attachments demonstrate our team collaboration, featuring ideas from multiple teammates on each one.
Our attachment design process is straightforward. First, we start with a simple prototype and test it by hand. Next, we build a sturdier version and test it on the robot with a basic program. Last, we identify and fix flaws and test again, improving reliability. A great example for our design process is with the coral tree attachment. We worked through these steps with 6 completely different designs and code before landing on one that worked consistently.
To ensure reliability, we tested each run 10 times. When attachment failed to achieve accuracy of 90%, we adjusted the mechanical design as well as program retesting along the way. For example, after multiple test runs and adjustments to both code and design, our raise the mast mission was inconsistent. We struggled to lift the mast the perfect amount. So then we made a major change, switching from a powered attachment to passive. It made a huge difference in our precision jump from 25% to over 90%.
At the start of the season, we analyzed all missions, brainstormed mechanisms, and rated the difficulty of each. Then we planned mission combinations to minimize travel time. We grouped missions in close proximity on the left and right sides of the board. By grouping missions, we launched 6 times in 2 minutes and 30 seconds. For example, run 1 collects krill, coral, and the water sample while raising the coral tree, while run 2 handles the coral nursery buds, shark release, scuba diver, the seabed sample, and the shipwreck.
This year for programming, we switched from the robot inventor clothing firmware to Pyrex. Huge shout out to Team Rockin' Robotics from Seattle for being a great resource as we made the transition. With Pyrex, we've improved our motor control, making our driving more precise than last year. Since Pyrex is similar to Robot Inventor, everyone was able to jump right in with what they already knew and help code at least one run. While we use block coding for our runs, Pyrex allows us to compare Python side by side with block coding, helping us learn Python for next year. We even coded our master program in Python and use GitHub discussion boards as a resource when troubleshooting. Here are some key programming features. 1, we use the gyro for accurate driving and turning on every run. 2, we use the color sensors for line squaring by the whale. 3, we use a motor stall detection program. For example, on the Trident, if the motor can't race enough, it detects the stall and aborts just that step, preventing the whole run from failing. And 4, we also use multitasking, allowing multiple motor movements at the same time.
As you can see, with Hans and runs, we become even more famous than Arnold Schwarzenegger, and we hope that we pumped
You up! Any questions?